Okay, for the bell work today, you guys, these 6 problems, these are the basics. Everything we've learned so far, the basics of trigonometry. If you understand these, it'll make everything else a lot easier, so make sure you're getting this down. You should know how to put those in your calculator now. Does everybody know how? So the cotangent of 34 degrees is 1 over the tangent of 34 degrees. Secant is 1 over the cosine of 31 degrees. Cosecant is 1 over the sine of 12 degrees. All right. Someone asked about problem 26. We're supposed to find the 6 trig functions of 330 degrees. So I've written them out here, sine of 330 degrees and so forth. So we're going to start with sine, and we're going to get our unit circles out. Get your unit circles out. I put one over on this side. There's one on the bulletin board over on that side now. But if you notice, 330 degrees is right here. This is 330 degrees. And sine is defined to be what? The y-coordinate, which is -1/2. So we just take the y-coordinate, which is -1/2. Any questions about that? Do you guys understand what we're doing? Okay, cosine of 330 degrees is defined to be what? The x-coordinate, which is square root of 3 over 2. Tangent is defined to be what? Y over x. Well, we already know that y is -1/2. We know that x is square root 3 over 2. Now we're going to have to do some simplifying here, right? So remember, what do I do to simplify a fraction divided by a fraction? Kayla. That's exactly right. So the numerator times the reciprocal of the denominator is what she said. So all I did is flipped over square root of 3 over 2. So the 2's cancel out if you notice this. And you're left with -1 over the square root of 3. Are we done?
No, because you can't square off.
Okay, so we have to rationalize that. So what do we do to rationalize it? We times top and bottom by what? The square root of 3. That's our 1. Square root of 3 divided by square root of 3 is equal to 1, right? So we can times something by 1. It's just a different looking one. And we can multiply straight across. -1 times the square root of 3 is the negative square root 3. And square root of 3 times the square root of 3 is 3. And there's our answer as far as tangent goes. This is how you have to leave all your answers, is in terms of square roots when you're working with trigonometry, unless it's a real world application problem. Even then, it depends on the situation. But on your standardized test, this is the way they're going to leave them. So make sure you understand the format. Okay, so cosecant of 330 degrees. Say that again. Okay, it would be the reciprocal of sine, which is going to be -2. Good. How about the secant? 2 over the square root of 3. Yeah, so we're going to times the top and bottom of that one to rationalize it by root 3. And that's going to give us 2 root 3 over 3. Very good. Some of you guys are getting this down. Okay, the cotangent of 330 degrees. You guys, I want you to see a quick trick. Everybody look up here. The cotangent is going to be the reciprocal of this, right? Do you remember right here? Remember this part right here? That was originally what we got for the tangent, right? And then we had to rationalize it to get this. Well, if we flip that one over, I'll have the cotangent, right? So what is it going to be? It's going to be negative root 3. Negative root 3. It's going to be negative root 3 over 1. what is over 1 is just division by 1 is the number itself. So we've got our 6 trig functions. Okay, that's how you do those. Okay? If there's a different kind of problem than that one, I will look at that. Otherwise, let's move on. Okay. Okay, our objective for today is written right up here. I have it on the smartboard too, but probably the better way to say it is where I have it written over here. Today we will find the values of the 6 trig functions of an angle in standard position given a point on its terminal side. So let's contrast that. We learned how to find the 6 trig functions on a unit circle. Now we are going to take that and we are going to do this for an angle that is on a non-unit circle. Okay? So let's say the inside circle is a unit circle. Okay, and let's say I have an angle right here. Angle theta. And let's say I drop vertical line straight down right here. So I have a right triangle there, and also I drop one down over here, so I have a right triangle right there. Okay? Now, obviously, this point right here and this point right here are going to have different coordinates, aren't they? So we could call this one right here, we could call the first one x1, y1. And we can see that this one right here is x2, y2. They are different coordinates. However, what I want to know, we want to know, are they going to have the same sign? Is theta of the smaller, in the smaller triangle, going to have the same as theta for the bigger triangle? Okay? Well, look at the small triangle. Is the angle the same for both triangles? Yeah, angle theta is the same for both triangles, right? Okay. The coordinates are different. However, we know that the ratios should be the same. We learned that when we were talking about the unit circle. Okay, the ratios, the sign's going to be the same for any angle. I mean, if you choose 71 degrees, it doesn't matter how big of a triangle 71-degree angle's in, it's going to have the same sign because the ratio of the opposite over the hypotenuse is going to be the same. So we know that the sine of theta is equal to opposite side, which is this side over here, this side over here, which is going to be y1 over, and let's remember the smaller circle is a unit circle, so the radius is 1, right? R1. Which we also know that in the bigger one, it's y2 over radius 2, right? We know that those have to be equal. y1 over r1 has to be equal to y2 over r2. And so we're going to use that to define the 6 trig functions when you have a point on the terminal side of an angle. See, this is the terminal side of the angle right here. Point that's on the terminal side of the angle when it's on a non-unit circle. So Example, we're going to find the values of the 6 trig functions for an angle theta in standard position if a point with coordinates 5, negative 12 lies on the terminal side. I'm going to back up a second, and we are going to define these. So I want you to write these in your notes right here. Sine of theta equals y over r, right? On the unit, how's this different than the unit circle when we did the unit circle? What's the definition of sine on the unit circle? It was y over 1, right? Because the radius was 1. But now all of a sudden our radius is not 1, so it's going to be y over whatever the radius is, right? So what's the only difference is that radius is not 1. So what's the cosine going to be? X over r, right? Instead of x over 1, or the x coordinate, it's going to be x over r. Tangent is going to be what over what? It's going to be y over x, opposite side over adjacent, right? Okay? Which function's reciprocal of sine? Cosecant. So cosecant's going to be what over what? R over y. What is it on the unit circle? On the unit circle, it's 1 over y, right? Okay. Secant's the reciprocal of cosine. So it's going to be r over x. And the cotangent is the reciprocal of the tangent, so it is x over y. Which of these two functions are no different than the unit circle? Tangent and cotangent, same exact thing, x over y, right? And y over x and x over y. So those are the same. The only difference on these others is where there was a 1 before, now there's an r, because our radius is going to not be 1. Raise your hand if you understand this. Okay, well, we're on the right track then. Okay, so here we go. Find the values of the 6 trig functions for angle theta in standard position if a point with coordinates 5, negative 12 lies on the terminal side. I want to see if you guys can do this in your groups. Find all 6 trig functions. We have a point, 5, negative 12. I'd graph that point. I'd draw your right triangle, and I would do the 6 trig functions, okay? I'm going to give you about 5 minutes. I'll come around and give you hints when you need it, but I want you guys to see if you can figure this one out. Go. All right, you guys did a good job on that. Let me show you guys. Okay, some of you had a hard time visualizing this, so let me just talk about it for a second. If the angle's in standard position, we're going to graph the point from 5, negative 12. So we go over right, 1, 2, 3, 4, 5, and down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It's going to be about right here somewhere, right? And so we're going to draw a line from 0, 0 to our point 5, negative 12. Now we're going to use, this is our angle theta. We're going to use reference angle because I don't know if we got to the angle by going around this way or if we went by going this way. It really doesn't matter because we're using the reference angle. Remember, the reference angle is between the x-axis and the terminal side. So we're doing that one, and so we're going to drop our line straight down to here, and there's our right triangle. We know that since this distance, we went 5 units to the right, that's 5. Then we went 12 units down, that's negative 12, right? We use the Pythagorean theorem to find that distance of 13, right? So the r is 13. So now I have I have x, y, and r. X is 5, y is negative 12, and r is 13. And so we have those, and so now when I go to do sine of theta is equal to opposite side, or y over r, and so forth, right? Okay, you guys did it. Good job. For the most part, you guys did excellent on that. So hopefully now we can get the idea. So let's go to the next one. Okay, with your shoulder partner, do problem number 9 on page 296. Okay? Problem number 9 on page 296. I'm going to give you a minute to do that one. Okay, you guys did a good job on that one. Yeah, did you guys check your answers in the back of the book? Make sure they're right. You should always do that on the odd problems. Okay. Suppose theta is an angle in standard position whose terminal lies in quadrant 3. Okay, it's telling you what quadrant it's in. If sine of theta equals negative 4/5, so this time it's giving you the sine. Find the values of the remaining 5 trig functions. I'm going to see if you guys can figure this out in your groups. Okay, in your groups, see if you can do this one. All right. So, you guys did really, really well on this. I was impressed. Let's talk about this. Okay, all eyes right here. I know most of you guys have this, so you're thinking we don't have to learn. But, okay, if sine of theta equals y over r, and I'm given that the sine is negative 4/5, then I can say that y equals what? Negative 4. And r equals 5, right? So I'm going to go in this thing, and I know it's down here somewhere. I don't know exactly where yet, but I know it's down here somewhere. If I draw my line there, I know that this line's negative 4, and I know this one's 5. I've got to find the x distance, right? That's what I need. So I use the Pythagorean theorem. We find out it's negative 3 because you went in the negative direction to get there, right? So now we have x equals negative 3. Now we can find cosine, tangent, and so forth. But just kind of give you a visual. I usually like to draw a picture. We knew it was in the 3rd quadrant. It told us that. We knew the sine was negative 4/5, so we had y and r. Drew a picture. We know x has to be negative because it went in the left. And we can finish it out from there. Good job. Okay. Number 5, with your shoulder partner, do number 12 on page 296. Go. Okay, on this one, we were given that the cosine of theta equals a negative 1/2. Is that correct?
Yes.
And that we're in quadrant 2, right? Well, there's an easy way to do this one, and there's a longer way to do this one. I think most of you guys did it the longer way. Okay? But let's do it the longer way first, and then I'll show you the easier way. Because since most of you guys did it that way. You know, first of all, that it's in quadrant 2. So you have an angle. I'm going to use a different color. You have an angle, quadrant 2. If we're using the reference angle, we draw a picture like this. Down to the x-axis is our right triangle. And we know that cosine is equal to adjacent, or x over r, right? So we know that this is a negative 1 because we went in the negative direction, and we know that r is 2. And if you use the Pythagorean theorem, negative 1 squared plus y squared equals 2 squared, we'd get 1 plus y squared equals 4, minus 4 from both sides, and we get 4 minus 1 is 3, right? And then we take the square root of that. We'd get y equals plus or minus the square root of 3. Now, is it plus or minus?
Plus.
It's plus because you're going up, right? The y value is going up, so you know it's plus. Now, we could go from there. Sine theta equals y over r, so square root of 3 over 2. Tangent theta equals y over x, so square root of 3 over negative 1, which is going to be a negative square root of 3. And you can continue that pattern and get the rest of them. You guys want to know the easy way to do that now? The easy, fastest way? The easiest way is recognize that this number right here is a coordinate on the unit circle. Cosine, where's the cosine? In quadrant 2, where's the cosine of negative 1/2? At 120 degrees, right? And so y is going to be square root of 3 over 2. And r, okay, r would be y divided by x. And you could get it that way, okay? So that is the fastest way to do it, is to recognize that it was a number on the unit circle. Got it? Cool. On the ACT, I would recognize, but you know what? You're going to have the unit circle memorized, right? Because I told you we're going to be memorizing it. Let me ask you guys one more question. If I was to ask you guys, well, never mind. That doesn't apply to this. Never mind. I'll come back to that question later. Here is part 2 assignment for 5-3. 31 through 43 odds and problem 49. Now notice I give you odd problems, so check your answers on all of them, please. Okay? Now, make sure you know how to do it.